Okay, so I was asked to do question 13 from Physics Higher. Let's have a look at it. Where is it going? There it is. There it is. So, diffraction is one of the wave properties of light. What is meant by diffraction? So, diffraction is the spreading out of a wave as it passes through a narrow gap, or the bending of a wave as it passes around an object. And then part 2 is an experiment to demonstrate the wave nature of light. I see that this came up in 2012 ordinary level. Question 7, 2012 ordinary level. So you can have the marking scheme there. Apparently the first part was what's diffraction, and then to describe the experiment. So can't imagine the marking scheme would differ too much from this. What was it, 56 marks? So that's for the full question though. Yeah, be pretty similar. Yeah, I think. Yeah, no, that's what you observe. Yeah, patterns on the screen. The interference pattern, the fringes. Yeah, it looks like it's exactly the same. Make sure we're not missing anything. Yeah. So yeah, part 1 and 2. Um, both come from 2012 ordinary level question 7. The next part is the convergent lens. So I just took the image from the book, Physics Plus. So that's the image there for the convergent lens for the telescope. Basically, the idea is we treat a distant object as parallel light rays, approximately, and then the convergent lens. This is the diagram they're looking for you to draw. So, yeah, that's it. Now, so the first 3 parts are really just bookwork. Part 4 is a calculation. I think it's just calculate the length of this pendulum. So the pendulum formula, T equals 2 pi root L over G. T squared equals 4 pi squared L over G. So L is T squared times G over 4 pi squared. So T squared is 4 pi squared L over G. L is T squared times G over 4 pi squared. So let me just take out my calculator. I think we were told that it is 2 seconds. Again, we're not clear on the significant figures. I'm just going to take 3 significant figures. What do we say? 2 squared. So that's 4 times 9.8. 4 times 9.8 over 4 times pi squared. Yeah, the length of it is 0.993 meters. Okay. And that's that done. Titan orbits Saturn every 15.9 Earth days. The surface of Titan is that many. Okay, I think we might need to draw this. Okay. So you have Titan, the moon. Titan orbits Saturn every 15.9 Earth days. So orbiting Saturn. And that time is 15.9 days. That's definitely a 3 significant figure number. The surface of Titan is that many meters above the surface of Saturn. So I assume they mean from here to here. Just 1.16 times 10 to the 9 meters. Now, I'm not sure why they did this. The surface of Titan above the surface of Saturn. Did they mean to? Oh no, yeah, it's hidden down the bottom here, and you're given the radius of Saturn, and you're given the radius of Titan. So that's the distance between the surfaces, but I'll just call it small d. Although I think in the formula they use small d as the distance between the centers. The distance between the centers I'll call r, and that will be 1.16 times 10 to the 9 plus the radius of Saturn and Titan. So that's 58200 times 10 to the 3 plus 2570 times 10 to the 3. Okay, so let's just type that in on the calculator. 1.16 times 10 power 9 plus 58200 times 10 power 3 plus 2570 times 10 power 3. Yeah, it's given to me as an awkward number. 122.077.0000 meters. I'll definitely leave that answer up on the screen. On the calculator. Okay. Right, so what are we looking for? Calculate the mass of Saturn. This uses Kepler's law, which I'm pretty sure is in the formula book. I wonder, I don't think I can remember it. It's T squared equals, what is it, G M over R cubed? No, GM over 4 pi squared R cubed, is that it? I'm going to check the formula book to see now if I can find it. Okay, let's have a look. All right. See if it's in here somewhere. I can derive the formula, that's not a problem, but it saves a lot of time if it's one that we can just use straight from the book. Here's the mass, light and sound, heat and temperature, forces, gravity. It's not called Kepler. Oh, I nearly had it. The 4 pi squared is on the top and the GM is on the bottom. So I wasn't a million miles away. 4 pi squared on the top, GM, and then R cubed here. Okay, fine. And then we're looking for the mass of Saturn, so we're looking for the M. So the M will be 4 pi squared R cubed over GT squared. Alright, let's see. Let's take out the calculator. Okay, 4 times pi squared times my radius, or the R I should say, cubed over G, which I think is 6.67 times 10 to the power of minus 11, multiplied by the time squared. And the time is 15.9 days in seconds times 24 hours times 3,600. And let's get the gravitational constant if we can. If we can, that is. Not zoom out. Oh dear. know what's happened. Let's just gravitational constant 6.6743. Okay, 6.6743. Right, so that is 5.70 times 10 to the 26 kilograms. And we can check if we're right in Google if we just type in mass of Saturn. And are we close? 5.70, 5.68. That sounds good to me. The acceleration due to gravity on the surface of Saturn. Okay, that formula, acceleration due to gravity, G, that's gm over r squared. Now we know the mass of Saturn, because we just worked it out, and the G is 6.6743. 6.6743 times 10 to the power of minus 11 times the mass of Saturn, and then the radius of Saturn is given here, 58200 squared. 11.2 meters per second is what I got. 1.2 meters per second squared. Acceleration due to gravity on Saturn. Okay, that's a little bit different. So it makes me think I typed in something wrong. Perhaps. Let's have a look here. Let's see. Okay. Let's see if this is right now. This is not coming up as easily as you would think. Go back to the first result. The NASA page should be good. Okay. Saturn acceleration 8.96. But is that okay? That is the right formula. 6.6. Okay. 582 times 10 to the power of 3. Okay. And then the mass is 5.70 times 10 to the power of 26. Double check. Yeah, well, that's what I'm getting. I think I have the right formula. Let's just double check that too. Gravitational field strength formula for the G. Yeah, that's it there. GM over R squared. Yeah, so I wonder why my answer's different. Oh, there you go. That looks better. The surface gravity on Saturn is 107% that of Earth. So let's see. 9.81 times 107% is 10.5. Not exactly the same. But, okay. I guess we'll just continue. The acceleration, the period that the clock pendulum would have. Okay. So let's get that now. The period would be t equals 2 pi root L over g. 2 times pi root L over g. I think it was like 992 or something. I have to go back in time to get that L. Let's see if I have to go too far back. Let's clear this off. It was probably just the screen right before it, wasn't it? Can't remember what was after the 99. 993, not 992. Yeah, so that means then that if you calculate the time using that formula, but with the g being 11.2 instead, you would get the time is 1.87 seconds. So that's just using the same formula, same length. Pi is obviously the same, just changing the g. Okay. Right, I think I've answered everything. So I've gotten the period that the clock would have on the surface of Saturn, the acceleration due to gravity on the surface of Saturn, the mass of Saturn. So the only thing I'm not 100% happy about is just knowing that the g is right. But I think everything else is okay. Yeah, okay, I think this question's finished. Let's see. Diffraction is one of the wave properties of light. Was meant by diffraction. Draw label. Yeah, so that was the ordinary level question in 2012. Diagram I took from the book. Length of the pendulum I calculated using the formula. The mass of Saturn I calculated and checked on Google. That's right. The acceleration due to gravity I calculated, checked on Google, couldn't confirm it for certain. And that might affect the last answer here. The period that the clock would have on the surface of Saturn. So, yeah, okay. Any problems, let me know. I think this one is finished though. I'll stop the recording now.